Hello and welcome to Identerati Office Hours. I'm your host, Mike Schwartz, founder of Glue. Today is episode 169. The topic today is QR code identity presentation. Our guests today are Resham Chugani, product manager at MOSIP, and Jeremy Jocelyn, executive director of Open SPP. Welcome, guys.
Thank you. Happy to be here.
Hi, Mike. Thanks for having us. Good to see you, Jeremy.
So this is a bit out of order. If people are wondering why we're doing episode 169 after episode 177, the reason is because we've been holding this specific episode number because it's about a standard called Claim 169. So we will forever remember that episode 169 is about Claim 169. So that's why it's out of order. We meant to record this at MOSIP Connect, but we just got too busy, and we tried. Maybe we were too optimistic about how many we could record. We only recorded one episode there, so we're doing this one now. But before we dive into our discussion about QR codes, we like to ask our guests to introduce themselves. So let's start with you, Jeremy. You're first in alphabetical order. So tell us a little bit about your career trajectory. How'd you get here?
Okay, thank you very much. So I'm a software engineer. I started a long time ago. I started working mainly in open source, working on open source software like open source wiki, open source enterprise portals for governments, for large organizations. Then I moved to Asia for a lot, and where I'm still based. Started a startup in Singapore, doing things in the space of CRM, email, and sold the company to Sugar CRM and AKKR. Then after I got into working more in humanitarian sector, so with some university friends, we started a company where we started working on humanitarian, working with a lot of the UN organizations to build their system. And this is where I got into working on offline applications, offline identity. Actually started, I think, 7 or 8 years ago. I was involved with the verifiable credentials and started a project called ID Pass that was doing quite similar to Claim 169, but not standard, not as good. And then got into creating another project, which I'm focusing on, is Open SPP, which is social protection platform in open source, where we do a lot of work in agriculture, social protection, emergency response. Great. And here I am now.
Sugar CRM, I haven't heard that in a while, but we actually, Glue is a Sugar CRM user when we started in 2009. And you're reminding me that we met, I guess, at there was like an unconference in Bangkok a couple of years ago. And I remember you were the first one to tell me about the word DPI, digital public infrastructure, and I was like, what the heck is the new term? And then we subsequently registered with the DPGA and became a DPG ourselves at the Janssen Project. So thank you, Jeremy. Resham, how about you? How did you end up at MOSIP?
So on the personal front, Mike, I hail from India, and my professional background has been a little different. I come from about 18 plus years of experience in product management in various domains, right from aviation to mobile app development. And somehow identity became a very natural space to sort of apply those skills. It sits, I think, at an intersection of technology, policy, and maybe societal impact. So I originally got into the identity space when Triple IT started off MOSIP to sort of address the global identity issuance gap back in 2018. So I've been with them since its inception. And I've been a part of the journey since its early days, and it's been sort of fascinating to see how the ecosystem has evolved. Uh, Organically, Claim 169 happened during this journey, and that's how it started off. So yeah, that's me, and looking forward to the conversation here.
So when I first heard that you could present identity information in a QR code, I was a little bit skeptical. um,
Yeah.
just because I think of QR codes as like a font almost, like it's a way to write text, but it's a font that's only readable by computers. And so I guess maybe Resham, we can start with the first question for you is what was the business goal that you were trying to achieve with this technology, and how did MOSIP get involved? Why did MOSIP think it was an opportunity?
So, Mike, what happened was as MOSIP deployments expanded across different countries, we sort of came across a lot of offline verification use cases emerging more frequently. It became quite a conversational topic. It became very clear that instead of each ecosystem building its own proprietary offline credential format, maybe there was value in creating something that was more standardized, which could follow an interoperable approach, which could actually work across different implementations, right? So that is where Claim 169 fits in. Um, in simple words, it is a standard that defines how essential attributes, identity information can be securely packaged into a, let's say, compact QR code, and it could be verified offline. Uh, this QR code could contain a digitally signed bundle of identity data, which could then be verified to confirm the authenticity, which eventually leads to a lot of ease in service delivery. And because the QR code is self contained, I think it becomes sort of extremely useful in low connectivity environments and supporting use cases like cross border verification scenarios. So, if I have to quote, the core goal behind this work is to enable secure and reliable identity verification in environments where internet connectivity cannot always be guaranteed, right? So while still ensuring interoperability across systems and countries, and many real world service scenarios such as border crossings or field services or remote regions actually require identity data to be verified instantly, even when online access is not available. So this QR code quickly packs in basic demographic data sets, low resolution facial image, certain metadata, which could be about the version, and of course, a cryptographic signature. So,
Great. And before we actually dive into, I think my next question is going to be for Jeremy about how much data we could actually put in there. But maybe before I go there, even just this QR code could be presented from a device, perhaps, but it could also be printed, right? Isn't that the idea? And so not everybody has a device. So was the idea potentially that this could bridge people who maybe don't have a device?
Absolutely. I think the value and the impact here is that it could also be printed on any document. It could be printed on a paper or a plastic card, depending on the country. It could be presented, and it could be instantly verified, and it confirms that the data presented is authentic, in fact. So it doesn't just go with QR codes being presented as verifiable credentials on wallets or on smartphones, but the idea, of course, like I said, in cross-border use cases, uh, refugees may not have devices, right? So they would just be given printed papers with QR codes. So definitely, yes, offline verification, simplicity, and inclusivity is what we're looking at here.
So, okay, so the $1 million question here is, can you really, the only way to tie something like a QR code to an actual human is to have some type of biometric, connection back to the human being. And so the obvious, biometric to use here is probably an image of the person. I mean, I guess there's so much variance in how fingerprints are actually processed and read. The sensors vary so much. So I think image is sort of the obvious one. So I guess the obvious question is, how can we possibly put an image into a QR code? And let me point out that that image is going to have to be contained inside of a signed, let's say, container. In this case, it's a CWT, which is a CBOR web token, I think that stands for. And this is think of like a JWT, but more compact because it's using binary data. So Jeremy, I'm going to give you the hard question and say, how can we possibly put an image inside of a QR code, inside of a container?
Yeah. And maybe I will start by, yes, it's much better to have biometric into it to verify. But like, I mean, we already have a lot of documents like this. Like, I mean, I worked in project where they just put a number and like that's easy to copy. I'm like, yeah, and they're using it, right? So, and in some places, in some contexts, you don't want to put biometrics for security reasons also, right? So, but also like one of the advantage of Claim 169 is also you have the ability to encrypt it, right? So the data can be signed and can be encrypted. So that you have some ways to protect the biometrics, because like it's something important to think about, that the data need to be protected especially in some specific cases. But yes, on the image, I mean, technology has made a lot of progress, right? And so what we found is WebP seems to be the best compression we get at this small size, right? So it's possible. So you can basically get an image to 500 bytes, but the sweet spot seems to be more around 600 bytes. And then it doesn't improve so much. Like from the test I was doing, going like to 1000 bytes, for example, there is not that much improvement actually for matching. So yes, we can create images of 600 bytes now. There is a little bit of gymnastic to do this, to strip some parts of the image that is not really important, to properly crop the image, to properly align the image before, so that it's usable later, right? So from the initial research, it seems to, because it's so small, right? It works like if you want to have like a not so hard high level security, right? Like far of 1%, for example, right? If you start going like to harder, then like it quickly degrades and is becoming harder to use. But yes, you can do this. And I mean, a template, like a biometric template, you could potentially put a fingerprint or an iris. Actually, like the first project we did on this, before Claim 169 worked, we were using iris template. But yeah, I think it's working more like, yeah, iris, I think it's quite linked to the hardware you're using. So it's probably hard to do cross hardware, if I'm not mistaken. And I mean, the other option also is to store the template of the image, right? But then also, if you do photos, sorry, yeah, you can also store the template of the image, right? But the problem after is you're locked into one model, right? So, and probably if you would store the template, you're getting better quality results, right? Because you would get the template from a higher resolution picture.
When you say store the template, do you mean put in a URL and then have the verifier fetch the URL, or what does that mean exactly?
Yeah, so the matrix, right? So I mean, if you're using an algorithm like ArcFace, right? So
Okay.
the one I use for my experiment is ArcFace. So basically,
so the output of the algorithm versus the image itself.
Exactly.
Okay.
So the algorithm output an array of 512 bytes. So basically, this you could store it. I mean, no, it's actually higher. Sorry, it output a 2000 something, 2048. But what you can do is you can downscale it. So I did downscale it to int 8. So you arrive at 512 bytes. And so it fits quite well, and you don't lose that much quality. But but the problem is you have no choice. You have to use always the same algorithm, right? And if you're using, and most of the time, I think for face matching, it's proprietary algorithm. So like it really locks you into switching. So that's why I think like, yeah, storing the image is probably better. And the compression is quite good. I mean, if you don't mind showing as an example of compression, so people see the different examples.
Right.
Yes. So basically, this is from the LFW test. So this is the original image is the first one, so 75 kilobytes. And then like we can compress it. So by resizing it, compressing it, stripping some unnecessary information from the image in WebP, we get to this quality, right? So here's the pictures have been scaled up, right? So they're been scaled up like around 4 times compared to the normal size to see, right? But the number of pixels is the same, is the correct one. So yeah, you can already see quite a lot of things. The next thing I need to do also on this is looking more at different type of skins. So I'm using a test set that is more about more light colored skins. Would be interesting to see with darker skin, but so far so good. I'm quite impressed by what we can put in this QR code.
I have a question about this. The grayscale versus the color, they seem to be about the same size, but I would think the grayscale would be a lot smaller. What is the benefit of using grayscale in this scenario?
Yeah, so actually initially, and I had people who told me grayscale is working better, and like initially also I was thinking this, but actually color is working quite well. So basically, like to get the color, you have to reduce the quality of the image you're putting it right into the QR code, into the QR code. But it seems like it's very close. Like the differences is very close between the color and the gray. But it seems that maybe there is more information in the colors that is useful for the algorithm, and it's probably also linked to the fact that this algorithm have been trained on color images, right? So I don't think like many of these algorithms have been trained on that small pictures, right? Like it's kind of something specific, and probably also vary a lot by the algorithm.
Interesting. So I guess we'll move to the next question and say, is anyone actually using this technology right now? I guess in production or just printing the codes. Maybe Resham, you have an idea about this actual usage?
Yes, Mike, what I would like to say is Claim 169 is still relatively a little early in the deployment journey. Of course, it is gaining a lot of strong interest in the ecosystem. So, of course, the interest has been where the connectivity is inconsistent or offline identity verification is required, especially where governments are looking for interoperable standards. One country that comes up to my mind right now is definitely Ethiopia, who has attempted to implement it as part of their FIDA app. More details, of course, will emerge on the outcome. We are in discussions. Beyond just countries, Mike, we're also seeing a lot of interest from organizations working on humanitarian identity and cross-border verification. Like we are engaging with UNHCR and the possibility of issuance of refugee IDs, considering the implementation of Claim 169. They're also a strong member of our community working group as well. So I think it's less about one country adopting or deploying it in isolation and more about creating a global interoperable standard. And I think we hope to get there soon in terms of adoption.
So I remember hearing at MOSIP, maybe it was UNHCR who was quite excited about the possibility of using this for cross-border, and was kind of optimistic, I guess is the best word. So we'll see if we can actually achieve that in the future. But Jeremy, OpenSPP is a social payment platform, and I'm wondering It's clear to me how MOSIP got involved in this, but I'm wondering, like, how did you get dragged into this thing? What was the connection to OpenSVP, or maybe to one of your other projects?
Yes, I mean, the relationship with MOSIP has been for a long time, and we know each other for a long time with Resham. We worked on other projects with MOSIP for, I mean, I don't know, many years. Almost, I think I probably started being involved with MOSIP like 1 year after it started, something like this. But no, like, it's more for a need, right? A lot of the work we do, and coming from a humanitarian background, a lot of the things we do is related to working in places where there is lack of connectivity. There is, even if there is connectivity, it might be intermittent, right? So there is need for being able to verify this identity offline. One good solution we had before, and that an organization we worked with was using is, and still use actually today, is smart cards, right? But storing the identity on it, and like you have a lot of security with this. Problems is, and also for offline redemption, it's very useful, right? Because you can do it securely offline. The problem is it's expensive for most of the organization. So this is how I got started into looking for a solution that is like cheaper and easy to deploy, easy to and secure, more secure than just putting a number on a card, right? So this is how we got started. And people were using QR code, but oftentimes with no security. So yes, they put a QR code and with a number in it and like no signature, nothing. So we actually did a first QR code. So I was working on verifiable credential and trying to cram it before into a QR code. So that's like 6-7 years ago, something like this. But it was hard, right? And especially if you wanted to have biometrics to it. So we actually already, so we created a project, and it's still online on IDPass repository, where we're doing a QR code version with a signature where we could put, we were doing more iris and fingerprint to do this. And so this is how we got into this and like the need of this, but we then worked on other things and forgot about this work. And then when MOSIP, Resham, and Ramesh said like, hey, we're working on this, so that got interested again, because it's really a need, right? Like, I mean, a lot of people think connectivity is everywhere, but that's not the reality, right? And you also need, I'm for a solution that don't have to phone home to do things also, right? So, and this is something that can work totally offline. Nobody knows what you're doing, like a normal ID document, right? Like where you don't have to say to the government or to the organization that issued it that you're doing a verification with these people or whatever. So yeah.
For many, it's not centralized like an IDP, where when you log in, there's a record of that authentication. I have a smart card. You mentioned smart cards, so I guess something like that, right? But these cards,
exactly.
As you mentioned, like on the low end, they're going to be like $10 to $15 a card, and that's a really low end smart card with not many features. On the high end, they could go as high as like I think $125 per card. And that includes not just the creation of like the card itself, but the issuance process. Because in order for the cards, you have to, interview the person, you have to create the card, you have to give them the card, you have to activate the card. So it's not just the card, like the raw cost of the card, but when you look at the whole cost of issuing cards, it really adds up. So
at volume, you can get it cheaper at volume, right? Like like when we were looking at it, and that was before the problem with the chip production, we were doing this, but like it was like with good cryptographic algorithm where you could do biometric match on card, we were at around $2, but like if you ordered in hundreds of thousands or millions quantities, you could get to around $2. But it probably increased a lot since. And I remember discussing with NXP at some point about the price where you had a fingerprint reader on it. And at that time, it was like $30, but like in humanitarian, it's just not possible, right? But it's they probably increase a lot now.
Yeah. Well, it could be. I'm not a smart card expert. In fact, smart cards is a whole industry into itself. But yeah, yeah, I just want to point out that a lot of people, I think a lot, if we went back like 10 or 15 years, I think there was a lot of hope around issuing smart cards, and the cost of it, and also not just the cost, but also the fact that it's hard to update the data on the smart card too. So there's a number. I think the logistical challenges of smart cards are basically didn't live up. Yeah, I thought your comment was also interesting about QR codes, because I feel like people think QR codes are magical. They're like, oh, it's like who could possibly read this? This is so obscure. It's just a bunch of dots. So I think that there is this sort of like misunderstanding of QR codes, that this is somehow encrypted, machine only readable, but actually we need some type of structure in there, and identity presentation in there, which brings me to my next question. So Claim 169, we've been talking about it, but we haven't really explained where that came from. So as I understand, it actually came from the IETF. But Resham, maybe you could talk a little bit more about the registration of Claim 169. What did that actually mean? And how do we get interoperability? And how does having like a standard claim like this actually help us in the ecosystem?
Yeah, so Mike, having the claim and the specification registered with IETF was actually quite an important milestone, is what I would say. By registering it with IETF, the identity payload actually becomes a recognized standard. It becomes a standardized claim identifier. And rather than having multiple isolated standalone specifications, having something standardized gives room for interoperability across the ecosystems. What it means is that any system that supports CWT tokens can actually interpret the claim, and it allows for implementations to interoperate, right? So this is how identity standards move actually from just independent implementations to global interoperability. So if you're looking at cross-border use cases, it wouldn't really help if you had isolated specifications. Rather, interoperability comes in when you have a standard specification. So registering it with IETF actually brought that aspect of interoperability.
So let me just, what you said is accurate, but maybe a little abstract. So let me see if I could break it down a little bit. So I think our audience is familiar with JWTs, like a JSON, and that JSON can be signed or signed and encrypted even. And so in this case, instead of using JSON as the format, we're using CBOR, which is a more compact token format. But you could still think of it like JSON in that there are claims and there are values. And so the CBOR token, what it sounds like what you're saying is that the IETF has created a registry where different types of tokens can be registered so that we know what claims that they contain. I guess I wanted to ask a follow-up question here, is that MOSIP has created versions of Claim 169, and the latest version is 1.2. So what's the delta between the claims that are registered in Claim 169 in the IETF CBOR registry and version 1.2, or what's the relationship between those two things?
So Mike, we have introduced, as part of the latest version, we've introduced certain additional attributes into the claim. While 1.2, I would say, is quite a mature iteration. I don't think any version is truly final, right? So we are working with our working group. Of course, Jeremy is a very active member there. We have UNHCR as well. So we are taking in inputs from various stakeholders to bring in more additional attributes and refining the spec.
So just to be clear, at the IETF in Claim 169, there's some core claims that are defined, maybe first name, last name, birth, date of birth, and in version 1.2, you sort of say we're accepting these core claims from the IETF, but we're also adding some additional claims. Is that right?
Yeah. So yes, just to be specific, yes, we did have, as part of the initial version, we did have the core identity attributes like first name, last name, gender, date of birth, all of that. As part of 1.2, we gathered a lot of inputs on, supporting secondary language, let's say for certain attributes, or let's say a legal status or country of issuance. So there were certain attributes that went back and forth in terms of discussion. So today we brought in 5 additional attributes, and 1.2 is an iteration of an inclusion of these additional attributes, where we also support a second language. So let's say multiple language for specific attributes. Yeah.
Okay. So Jeremy, I'm going to go back to the more general question. What are the best and worst use cases for this QR code based presentation?
Yeah, so it's going to be biased to my usage, right? But I think for me, offline delivery of entitlement, right? If you talk about humanitarian or social protection, right? So it's a really good solution to deliver this without having to store biometric or even PII on a device, right? Because like the usual way is that people would go online, synchronize some data, load some PII, load some maybe some biometric information in a device, and then go with entitlement, go offline, and do the redemption, right? The beauty with Claim 169 is that on the device that know what someone is entitled to, they don't need to have any PII, no need of biometric information because the person is coming with it, right? So you just have to have the ID number and that's it. You're reading the QR code, you verify the biometric with the person in front of you. If it matches, then you can deliver the goods, right? So in terms of security and of distributing the biometric and the PII, I think it's brilliant, right? So very decentralized data, and for me, like that's one of the main interesting thing. So being able to do biometrics as a secondary kind of factor, I think like that's good. And also one of the very good thing is for crisis response, like the cost of issuing it is close to zero, right? And this is also what I love, because you could potentially go home to home, capture the information, print a temporary card on a piece of paper. It costs close to zero, right? And it's really good because you can do this just for a specific program, for a specific use case that is just a couple of months, a couple of days, whatever, right? And the cost is close to zero. And it can also be used for more longer term solutions, right? Like for participation on program and everything, right? So it's a lot of broad set of usage. In terms of worst application, right? I think, I don't know if it's an application, but yeah, like some of the things, the worst usage of it, more like worst application is the key management, right? Like, so people need to be careful with the key management, right? And like verifying the things, right? Because like people might just like, oh, I have the document, it's signed by someone, I don't know who, I don't verify it, and then it's basically like if it was not signed, right? So the key management is really key, and it's always, I would say, always kind of a complexity, right? Like, how do you manage this key? How do you disable keys that have been compromised and all of this, right? Yeah, and it's not for the duplication, right? So yeah, it's not made for this, but yeah.
We'll hit the trust model. I have a trust model question in store for you at the end, but Jeremy, you actually touched on a point about selective disclosure, how perhaps you could print a QR code that didn't release all the attributes. Resham, maybe you could say a couple of words about that. What would that look like? Because the QR codes are static. How would you actually achieve selective disclosure using QR codes?
Mike, I think Claim 169, the focus really isn't selective disclosure the way verifiable credentials do, right? Because the payload is fully signed as a bundle. But I think what's important to note is that Claim 169 is trying to solve a slightly different problem here, where the goal is to ensure that the document that's being presented is authentic and it's issued by a trusted authority. And in many real world scenarios, the challenge is not really selective disclosure, but it's about verifying that the document itself is genuine and it hasn't been fabricated, right? And in this model, I think QR code acts as that cryptographic proof. So let's say you have a verifier who scans the QR code, verifies the signature, and confirms that the data being presented is authentic. So this approach, I think, is useful, like we said, offline scenarios. You could have it also simply printed and presented on a document, while the QR code provides the trusted digital verification layer. I'll leave the trust part for Jeremy to talk about. But let's say you have a case where indirectly, I think Claim 169 can still solve for it. Limited disclosure can still be supported maybe during QR code generation itself, where different QR codes could be created for attributes which need to be used in a certain scenario. So let's say you want a country to provide access to an individual to social media websites to children. So age verification becomes a question there. So maybe the QR code could just hold the date of birth and the name, right? So limited disclosure can still be supported during generation of the QR code rather than during presentation. So yeah, I think beyond this, we are also exploring, along with our working group, we're also exploring possibilities of linkable QR codes with limited data or profile-based tokens. And for now, I think the focus is simplicity and offline usability, and hence selective disclosure could be supported, but maybe during the generation of the code rather than presentation.
Okay, so yeah, I think that's interesting. Maybe you have a couple of QR codes, maybe one you present for one purpose, maybe one you present for another purpose. And like you said, it is evolving, so we'll see, because sometimes the market thinks of different use cases than we as like standards developers or software developers think about. So we'll see how it develops. So Jeremy, you opened the trust can of worms, so I'm going to bring it back to you. You know, this is a question with all identity credentials. You know, how do we know which issuers we trust in a cross-border situation? You know, maybe there's some type of federation, or what have you seen any efforts evolve here, or what do you think the trajectory will be for establishing trust in the signature of the identity assertions contained in these QR codes?
That's a big question, and that's a big problem. I mean, I don't have the solution. If I had, that would be great. But there needs to be. It really depends how it is used, right? Is it used among like a close group of people who can verify the document, right? So this is a little bit easier. But opening it more is hard, and there needs to be some kind of authorities that kind of decide, right, like what is accepted and not. And like the spec Claim 169 stay away from this, right, because it's complex, and it's there is already a lot of different solutions for different use case, right? I think it's really, really depending on the use cases. For my use case, I use most of the time, it's kind of closed loop, right? So like we kind of know who is going to read the document, and who is issuing, right? So it's slightly easier. So like we can load it into the application that are reading the document. We can load the keys that are allowed to issue. We can disable keys if they've been compromised. So it's easier. For cross-border, I would say I'm not really competent to answer, but I guess it's a lot of agreement between organization and government, which is complex
TBD.
and outside of my scope.
TBD. Resham, did you have anything you wanted to add to that? And if you didn't, I also, before we break, the last question was about version 1.2 and sort of, is that final? You said it's stable. Should we expect a 1.3? And so trust model and sort of roadmap for version 1.2 or thereafter.
On the trust, I think cross-border use also requires a lot of trust frameworks and governance agreements. So participating countries also need to bring in those privacy and security standards. So I think minimal data exposure and user control over the data that is being shared is also primary when you look at cross-border use cases. Those are my 2 cents on the trust aspect that you had asked for. Specifically on version 1.2, like I said, it is evolving. It is not at a final stage. I don't think any spec would ever be truly final. So the only recommendation that we have is to check the versions and the fields inside the token that you're using. Try to ensure backward compatibility and design for a verification logic when you're implementing that can actually gracefully handle the new attributes that we bring in our upcoming iterations. I think this will just help ensure that your existing implementations don't break, while it could just fit into the evolving iterations that would be coming up.
Before we go to last thoughts, I want to agree and disagree with your statement about standards are never final. I'll disagree and say, actually, you get adoption when the standards are stable and final, because a lot of the benefit of standards is that developers write libraries to process them, and people who write software, they start to build support for these standards into that software. And it's the adoption and creation of this library and infrastructure to consume the standards that actually makes those standards really valuable. I've heard people say adoption matters more than standards. For example, things like JSON or Swagger weren't really standards at all, but they had so much adoption that they became de facto standards and then standards. So stability of the standards is super important. I would say one of the reasons why OpenID Connect got so much adoption is because they were so adamant about stability and about it hasn't changed that much. And that's enabled developers to build that sort of infrastructure of software around it that makes it really useful. But I'll agree with you. And I want to point back to my last episode about the challenges of quantum computing in cryptography. So by 2030, it's predicted that there'll be industrial quantum computers by state actors, especially. So, I won't have one, but certain states might have quantum computers. And those quantum computers will be able to take public keys and work backwards to find the corresponding private keys, and therefore be able to mint documents that look authentic. And so the question with standards becomes, how do we go back and update older standards like Kerberos or SAML or Claim 169 signatures? And so I think that in terms of schema, that we do need the stability to create the adoption. But on the other hand, in terms of crypto, I think that crypto is a constantly moving battle, where the compute power will require us to have to adapt some of these standards to the new reality of the decryption attacks. Anyway, that's just my 2 cents on this. And with that, let's go to final thoughts. Jeremy, I'll give you final thoughts. Anything you want to say or add, next steps, things, promoting your software project, whatever you want to say. Any last thoughts?
I think one thing about OpenID, I think the thing is that OpenID Connect is like from OpenID, right? And like how many years it has been in the making. But yeah, like different naming. So yes, but I think it had a lot of evolution to get there. No, but otherwise, no. I mean, I think Claim 169 is really interesting. So we did a library, so an open source implementation of it. So you can find it on the IDPass /Claim 169 repo. It's basically built in Rust and have binding in Python, Java, Kotlin, JavaScript. So you can use it in any language to generate it. And there is also a playground. So you can test it online easily to see how it looks like and how big they are in the end. So you can see how much the compression we can do. Thank you very much for having me and for this conversation. Very interesting.
Awesome. And oh, by the way, now's a good time to add that each episode has a wiki page, a GitHub wiki page with notes on it. It's glue.co/IOH- the episode number. And I have a link to the playground that Jeremy just mentioned on that on the episode notes. So if you want to play with it, just check out the notes. Resham, last thoughts before we break?
Yes, Mike, if there's one thing that I would like to highlight, it's that Claim 169 is not just about QR codes, right? It's about creating a mechanism for identity verification that works when there's no connectivity, infrastructure, devices, and maybe where resources are limited as well. So QR code is one aspect. Like I mentioned, we would be venturing into other mechanisms. But what we are looking at right now is inclusion at scale, where verification can work anywhere, not just where internet works. And final thoughts, I think it's been exciting to see how something that actually started as a practical engineering solution is actually evolving into a standard for offline verification. Another exciting part is that this is being built openly by the global community. Jeremy, you're a part of it. So the standard can actually evolve as more countries and ecosystems adopt it, like you rightly pointed out, Mike. We hope to get there soon, with the focus being inclusivity and broader impact through standardization. Of course, a call out to the community is to engage with us, provide feedback, and actually help the standard evolve for adoption. That's about it. Thanks, Mike, for having us here.
Awesome. And so I will just take this opportunity to quickly announce the next episode. We have Mr. NHI, and I will show the episode. Who governs the bots? This seems to be the topic of many episodes, how AI is impacting identity and governance. And Lalit Chota is a expert in non-human identity, so please join us on next Tuesday, actually. And I also want a quick reminder for people, please follow the live stream on LinkedIn or YouTube, whatever your platform you're watching on. That really helps us. And with that, I will say thank you very much, Resham and Jeremy. Thank you, audience, and we will see you next time.
Thank you, Robin.
Thank you.